My name is Nolan Hartwick, and I am currently conducting the Data Science and Visualization Review session for December 4th. Let's go ahead and begin. Today I plan to cover classes and the SQL Alchemy OMR interface, ORM interface, just a bit. So let's go ahead and begin. You should see a notebook on your screen, and the first thing I'm going to be covering is classes. This syntax should be pretty familiar to you by now. We're defining a class named dumb class, so named because this class really doesn't do a lot. In fact, all it has is this weird function called dunder repr dunder. Weird method. It's one of many methods in Python that are magic methods that actually hook into the standard library and let you do pretty simple things pretty easily. So for example, in this case, the repr function is going to be used to represent instances of your class. So whenever I have an instance of a dumb class object and I try to print it or view it from the terminal, it's going to call this repr function, and in this case, it's going to return this string. Now, here you can see that I created a dumb class object called DC. When I print DC, I get that repr. And when I try to view DC at the terminal, it outputs this as my output. This isn't very useful for this dumb class object because this dumb class is dumb. It doesn't do anything. But it is quite useful for future things when you have a class that actually does things. The other thing that this class demonstrates is how docstrings work. Remember that to define a docstring for a function, fib I, it's simply the first string that comes after the function definition. So this is a docstring. And that docstring like the help function. Fib I, this is a docstring. Similarly, the first string that comes after a class definition becomes that class's docstring, but it doesn't just include that string. It'll actually go through and look at each method and also include the docstrings for each of those methods along with the method prototype. So when I call help on dumb class, that it has the docstring that I created for it. This class is just meant to demonstrate the magic repr method. And it defines a method called repr, and then it has these other things that I don't really want you to worry about. But this is a method, and it includes the docstring for the method that I defined. Whenever you're defining your own class, if you ever show that code to anyone, you should include docstrings on the class and on all of your methods. You want people to be able to just look at your code and easily understand what it's doing. Now, that was a very simple example, and now we're going to move on to something more complicated. What I have in front of you now, or before we move on, do you have any questions, Francis?
I'm okay at this point. Just one. So the init function is technically just like any other function. We can name it however we like. It's just like a convenience. Is that right?
No. So the init function is one of the magic methods.
Okay.
That's why it has this double underscore. Whenever you see that double underscore, you're calling a magic method.
Okay, how about repr?
Repr is also a magic method.
How are they different?
They serve different functions. So the repr method is the magic method that the Python library uses to represent objects, The
Okay.
init method is called almost immediately whenever an object is created, and is generally used to set up the object, if that makes sense.
Okay, so it's already a predefined function.
Kind of, yeah. So
Yeah.
it might make more sense when I go through this stat class, which includes
Okay.
an init and a repr.
I'm confused because putting def in front is like you're defining it again. If it's already predefined, why do we have to define it? Shouldn't we just call it the slow intuitive?
Because it's not one, it's not really predefined. I'm defining it. I'm defining the dunder repr function, and the Python library knows how to access it. So that when I try to print it, it knows to call dunder repr.
Okay. Okay, I think I kind of get it. I'll read more into it.
Sure.
Thank you.
All right, so this is a much more complicated, much more functional class. It's called a stack. And basically, you can think about stack objects as if you have a pile of objects that have been stacked on top of each other. At any given time, you can only ever access the top element of the stack. And all you can do is add elements on top or take them off. That's what a stack is. And this class implements a stack. So the first thing that we do is create implement this magic method called init. And what this is going to do is set stack object, and it has an optional parameter called iterable.
Nolan, you're a little laggy.
What we do is we set self dot head equals none. Can you hear me? Francis, can you hear me?
No, I think you just went mute for like 2 seconds.
Can you hear me now?
Yeah.
Okay. Let me know if that crops up again.
Okay, thanks.
So this init is defining a couple values. Because our stack is going to be holding some number of items, it has a size, and it has a top item, basically. And right now, there are no items in it, so that top item is none. The first thing that I do, if an iterable is passed to the stack, then we loop that.
You're lagging again.
I was pausing.
Oh.
Sorry. So this add method is going to take an element and put it on top of the stack. And the way it does that is by updating self.head to be a tuple containing the item you added along with a reference to whatever the stack was before. So whatever the top what it was, that is now the second from the top. That item, you can. We also increase size.
Okay.
Does that kind of make sense?
Yeah. Okay. The difference I see in this example and the class example is that in the init function, there are only 2 arguments, which is self and iterable here. But then in the class example, I think it also included the head and, for example, head and size.
I don't know what example you're looking at.
Okay. What difference would it make if you also put, like, let's say, head and size as the argument of the init function?
Then I would have 2 more arguments named head and size.
Would that make a difference?
No, it would change nothing.
Okay, so you don't have to declare them as an argument there.
Yeah, these are like functions. When I have a function fib, I can have one parameter I, or I can have two parameters, I and x, or I, x, and some other param. It's up to you how you define the function, and it's up to you how you define the arguments for the method. All that's important is that the method is named init, dunder init. It can have whatever parameters you want. In this case, I wanted to be able to easily create stacks from like some iterable, so for example, a list, so I added that, but don't worry about that right now.
Okay,
so
but then
now
later, then you can't really pass an argument head or size into the function because it's only taking one, which is self.
Correct. Okay. You could not pass a head or size as a parameter.
Okay, so that's so those two variables are pretty much defined here.
Yes, I'm defining them here. I'm defining these attributes inside of the init. They are not defined by the user. They're just I'm defining those.
Okay, got it.
So
okay, see the difference.
Down here, I create a stack object from a list, and what this is going to do is take the first item, 3, put it on the bottom of the stack, and then it's going to take the second item, 2, and put it on top. So when I print the stack, you can see that I have this stack, 2 is on top, and then I have item 3. Does that make sense?
Interesting. Hold on a second. Oh, right there. Okay, you return. Okay, so the stack, for instance, that's like part of the string. Let me see. Can you show me the function again?
I'm sorry?
Can you show me the function, the method again? I forgot. Yeah, what it did. Okay.
So that iterable was a list.
Yeah.
And it takes the first element from the list and adds it, and then takes the second element from the list and adds it. And adding it is adding it to the top. Does that make sense? Imagine you have a stack of coins, basically.
Okay. So let's say you 3, 2, and 2, 1.
Let's just start with an empty stack.
And
then let's add some elements to it. Right, so we're starting with this empty stack. The first thing that we do is add 1 to the stack, which is going to put it on the bottom. And now we have the stack containing 1. Now we add, sorry, these strings are wrong. 2, 3. So now we add 2 to the stack, and now 2 is going to be on top. Now we add 3 to the stack, and 3 is going to be on top.
Okay.
So that's how adding works. And add is just a method that I defined.
Okay.
In this case, the pop is going to take the top item, remove it from the stack, and return it. So when I call x.pop, my stack.pop, I'm going to return 3, and I'm going to get left with this subsequent stack just containing 2 and 1. I removed the top item. And I can do it again and get 2, and now my stack only has 1 element in it. Does that make sense?
Yeah.
Okay, perfect. So that's just those. So this is just me defining the init, which is just doing some work to set up the objects, and a couple quick methods that I define named add and pop. which allow you to add elements to a stack and remove elements from a stack. These are normal methods that I defined. Now we're going to get into some magic methods. These are other magic methods that are like repr or init, but they serve different purposes. So this magic method called contains, or dunder contains, is going to ask me if, basically it's going to check if the item is in the stack. And it's going to do that by iterating through my stack and asking if the item is in it. And because I defined dunder contains dunder, I can create this stack 4, 5, 6, and I can ask, does my stack contain 2? And that's false. 2 is not in my stack. Does my stack contain 4? Yes, that's true. And the syntax that's happening here is 2 in X and 4 in X. Have you seen that? So this syntax should be pretty common to you. And the way that this works, like whenever you ask if X was a list and you did 4 in X, it's calling the list contains function.
Okay.
It's the same way, except because this is my class, I have to define contains. Well, I can. If you don't define it, then that syntax won't work on the class that you define. Similarly, we can also define this len function, which is going to return the number of items in the stack. And just like you can call len of a list, you can call len of a stack object, and it's going to call that function and print 3. In this case, because there are 3 items. Make sense?
Yeah. Okay, so dot size, that's like that's not really a variable. Is it a variable or is it like a property?
They're called attributes.
Attribute. Yeah, sorry, attributes. That's what I meant.
Yeah. So self.size is an attribute that I define in the init and set to be equal to 0. Whenever I add an item, I increment self.size. Whenever I remove an item, I decrement it.
Oh, okay. Okay.
So at any given time, self.size is accurate, and I can just use it.
Okay.
Now, these next 2 magic methods are part of supporting Python iteration. You know how you can say if I have some list named my list, then I can say for X in my list and iterate over it, right? Like 5, 6, 76. So I have a list. I can iterate over it using this syntax and print it. And in this case, I'm just printing the items. This should be very familiar to you. If you want your classes to support that style of iteration, you need to define these 2 methods, which I'm not going to go into depth on, but basically the dunder iter and dunder next method let you iterate over objects. You can read more about how these work in the documentation, which I've linked here.
Okay.
But because I have those implemented, I can create a stack object and I can iterate over it. So I have the stack 4 through 7. I'm going to iterate over it from top to bottom, 4 through 7. It's just a useful thing. Finally, there's this reversed, which is going to basically flip a stack upside down. And then this is, again, a function that I defined. And because I've defined it, when I call reversed on a stack object, it's going to invoke that reversed method and let me flip my stack upside down. So before it was 437. When I call reversed on it, it's going to be 734. Does that make sense?
Yeah.
All right, let's skip this add method for now and just go into this represent. So this dunder repr, this is the same thing you were looking at earlier, and hopefully you can see how this is different from init. This is a different magic method. In this case, I'm representing stack objects. And whenever I have printed a stack object, it's been invoking this function, this method.
Okay.
Like print x is the same as saying print x dot underscore underscore repr underscore underscore. In some respect, that's what print is doing. It's calling this method of whatever object you pass in.
Okay.
Yeah. I thought I'd go into this to try to explain how a lot of the built-in library functions work, like the len function, which you probably used a lot. It works because when you call it on a list, the list has this function, this method implemented.
Okay.
Does that make sense?
Yeah. Okay. So for those, you just need to put it there. You don't need to you don't have to write all the code because they're already in the library.
The code is just very simple. This method has one line.
Okay, how about the reverse one?
Reversed is a little more complicated. It's still one line, but what it's doing is taking advantage of the fact that stacks are iterable. So I can pass a stack to, I can make effectively a copy of the stack by passing itself to the stack constructor, the init. And it's going to reverse the order because it's going to take the top item and put it on the bottom of the new item, take the second item and put it on top of the first item, and so on and so forth. But that's how it works. But all of these methods are you both define them and implement them. They just happen to be very short implementations because these are relatively simple. What this is doing is relatively simple for any one of these magic methods.
Okay. And they all already Python library.
So the Python library knows to look for them whenever it sees an object.
Okay.
Like the len function is built into the Python library, and what the len function does when it's given an item, when you say len of item x is basically the same thing as saying x dot underscore underscore len underscore underscore.
Okay. Yeah, that's what I was thinking. Yeah.
Like that's literally what the len function does. And that's how all the built-in library functions work. And because they work that way, you can make classes you define work with the built-in library functions.
Okay.
You can read more about it in the documentation.
Yeah, I will.
These are quite useful when you're defining classes. But now that I think about it, it might be useful just to quickly state why we use classes. This is one clear example. Usually you use a class when you have some specific data and you have specific functions that only make sense in the context of that data. In this case, my data is this weird set of nested tuples that I create here in the add function. And all of these methods are interacting with that data. And because they're all interacting with that data, it makes sense to have a class that wraps both the data structure, the data itself, and provides methods that can be called given that data. Does that kind of make sense?
Yeah.
So the thing you really wanted me to cover, and I'm gonna do my best to try, is a really complicated topics.
Yeah. Yeah, we went over that in like 5 minutes.
Yeah, we're gonna continue going over it in class, but I'm just gonna try to go high level here. We were using the SQL Alchemy ORM, and ORM stands for Object Relation Mapping. It's a dumb acronym. It's an ORM. And I'm going to be importing a bunch of methods from SQL Alchemy that use the ORM. And I'm also going to be importing PyMySQL because I want to connect to MySQL database, my local copy, and I'm connecting to specifically the review database, which should be empty. Hooray, it's empty. Nope, this is wrong. This one. The point of these ORMs is to give you an abstracted layer over the SQL so that you can write code that looks like it belongs in your language and more easily do some of the operations that you would be doing with SQL-like data. Like, the point is to make it easier to do things. And in this case, I think I have a pretty simple example here that will demonstrate it. So I just imported a bunch of stuff. The next thing I'm going to do is use this SQL Alchemy ORM interface to define some classes, which are going to be used to both package data that I am sending and receiving from the MySQL server, as well as define relationships within that data. So I'm trying to create, here I'm basically trying to create a little application that lets me keep track of some number of human owners and what their pets are. So I have two tables, owners and pets.
Okay.
And my owners, every owner gets their own ID. Every owner has a name. Every owner has a contact info, a phone number. And every owner has a relationship to some pet or some number of pets. And I specify that here. Now, every pet also has an ID. Every pet has a name. Every pet has an owner. And you'll note that I use a foreign key here because I want every pet to have an owner in my database. And I also have this relationship defined by that foreign key, which lets me, when I eventually start working with this, you'll see that it will let me access the owner given any pet. And it will do it very easily. I don't have to do any joins or weird select statements. It's just going to be, it'll be like working with any other attribute from any object. So let's just define those classes. This is me connecting to my local database and doing some setup. And now we need to populate some data.
Nolan, sorry to interrupt. Just to clarify.
Yeah.
So in the return statement, that's a SQL. That's a SQL command, right?
This repr.
Yeah,
No.
in the return. What is it?
This is just like before. Whenever I have a pet object, I'm going to, whenever I print a pet object, I want it to generate this string and use that to format what it shows me. This is just a pure Python thing using that magic method from before.
Okay.
Just
don't think I've seen this formatting before.
So this is a formatted string. Ignore, this is just a normal character. This is just a normal string. And then we have, this is all normal strings, and I'm accessing self.id, self.name, self.phone number. This looks much more complicated than it is. It's just a formatted string.
Okay.
So I'm connecting to the database, and now I need to make some data. So, oh, sorry. Let's go down here and fix this. I don't want to add my brother. I want to add me. I want to add my dog named Rio. So I'm going to create a new owner object by calling this owners class and passing in name equals Nolan and phone number equals 8675309. I'm going to add me to the database and commit my changes. I can then create my dog, my pet named Rio, and I am its owner, so I'm going to give it my ID, which can be accessed like any other attribute in any normal class. I then add that data and commit the changes. So when I execute this and I update my table, you're going to see that I now have two tables called owners and pets.
Okay.
And owners has the following information: ID, name, and phone number. I'm in there. And pets has the following information: ID, Rio, and this owner ID, which is basically a link to me in the other table. And that's just me executing SQL in a weird way. But here's where the magic happens.
Okay.
So I can do queries by just passing in the class that I want to query on. So I have this owners class, and when I pass it to query, SQL Alchemy knows to look at the owners table and get data. And I'm going to do this for owners and pets. You can see that I have the following data in my tables, and that's not all we can do. Because I define these as classes, SQL Alchemy also knows to grab that data from the table and put it inside of an owner object and put it inside of a pet object. So when I get the first item from that list, I get me. When I get the first item from the pets list, I get my pet Rio. And those are fully fledged objects, just like any other object with all the attributes that I defined, including these really cool ones called pets, which is actually just going to be a link. It's a list containing all of my pets. And Rio now has this item called owner, which is a link to me. And this still works in data. So like I can add my brother and I can say that he has a dog named Saxon. And when I go back, I can refresh.
One more entry.
Huh? I'm sorry?
And then you'll be adding one more entry to it?
Yes, now there's another entry.
Okay. So you're building tables using Python.
Yes. That's what's happening. I just added more data. So now when I run this, I'm going to get even more data. So now I have two owners, Nolan and Kenton, and I have two dogs, Rio and Saxon. But the link between me and Rio is staying there. I can ask who are my pets, It's Rio. Who is Rio's owner? It's me.
Is that how databases are normally populated?
No, this is the magic of ORMs. This is the reason we use them, because otherwise you would have to do this clunky merge selection call and this complicated.
Oh yeah.
And because of the way that I defined these objects, because I defined it with the relationships built in and specified, it just figures it out and does it for me, and I can easily access them, which is the reason we're trying to use them. And it's going to keep working even when I say, like, I want, so what if I just got another dog, let's say, okay? So I can add a new dog. So now I just added another pet. So now I have 3 pets and 2 owners. And if we go back here, we can refresh this. And we can see that there are now 3 pets.
Okay.
So basically what this is saying is that I have 2 dogs. As a result, when I run this, and I say, who are my pets, me.pets, I don't just get Rio, I get both me and I get both Rio and Rayleigh.
Okay.
And this is just, it understands the relationship and makes it really easy to go in both direction and figure out who are my pet, who are some users' pets, who is some pet's owner.
Okay.
I know this is kind of complicated.
Yeah, I can sort of see the value of this, but it's hard for me to believe that this is the easier way than to just merge tables.
Yeah.
In the moment.
In the moment, I can see where you're coming from, but this is how people like to do things. It's how I've done it before. I don't really know if it's easier, but it's common, and it is. Once you get used to it, it's a significantly more. It just kind of makes sense to be able to say that I define that foreign key instead of having to look. I just want to be able to say, I have me, who are my pets? I just want to know that.
Okay.
And if you don't have these relationships, if you don't use these ORMs, then you're going to have to
keep writing SQL commands.
Yeah, you're going to have to keep writing SQL commands, and you're going to have to keep doing that whenever you say, like, what if I want to know, like, imagine you have this database with 30 tables, and each table is dependent on 2 other tables, basically. So you like a web of tables. Writing SQL queries when your database is really complicated gets to be a pain. Whereas as long as you are specifying the relationships well, as long as you're using these ORMs in the way you're supposed to and building them correctly, it's always easy to follow the relationships. Like I can even say me.pets. I can ask who is my pets0.owner. This is saying, look at me, look at my pets.
Okay.
Look at my first pet. What is my first pet's owner? And that's just going to work. I can say, okay, I have that owner. What's their name?
Oh, wow.
That's the power of these, and that's why we're learning them. And they are complicated, but they're also very powerful and very useful. And that's gonna about do it for my lesson. At this point, I'm going to.
I got what you meant by like this being like application.
Yeah, it's you can just keep following these relationships, and it makes it really easy, much easier than figuring out how to nest that SQL query again in order to get the data that you want. And then, oh no, I don't actually want that. I want to follow that data to some other table. And this is an easier way of thinking about it.
I see. I have a general question. So when people talk about SQL programming, is this what they're doing?
Some of the time, it really depends. They might just be writing SQL scripts.
Oh, okay.
But like,
are we gonna cover a lot on this later?
I am uncertain how deep we're going to be going into this. I haven't looked at this week's lesson plan in detail. I apologize for that, but I just haven't had time.
Okay, got it. Because yeah, I can't say I have this all figured out at the moment. And yeah,
No.
if it's the expectation for us to get this, then I probably need more time on this.
You're going to be working with things like this for the next few weeks, basically, because every web development framework uses an ORM.
Okay.
Development framework. I shouldn't say every. I don't know that for certain. Everyone I have ever seen uses an ORM to make it easier to think about all of the data that you're trying to store for all of your users and how it's all related to each other.
Okay. So we have a few more weeks of time to learn this thing.
Yes, you're gonna have time.
Okay, good to know. Good to know. Okay.
Monday's lesson was just meant to be a simple introduction. It wasn't meant to be the total lesson, or even close to the total lesson.
Okay, good. Okay, then can you quickly explain like views in SQL? Yeah.
So a view in SQL is basically just it's like a specific select statement that you stored. And now that you've created that view, you can easily access that select statement and easily treat it as if it's a table, even though it's really not. So like I can do create view. Oh, I don't remember the syntax exactly. I'm gonna have to look it up.
Yeah, create view as whatever queries you wrote. Yeah, I think it's. And then you access it as a table.
Well, you can kind of access it like a table. You can access it like a table, but it's not really a table. So create view, test view as select star from let's say use review DB. Let's join owners on start. In theory, this works. It did not, and I can't see. What does that say? Ah, duplicate column in. Okay, so let's do select from pets P owners O not ID What am I other? What does my data look like?
Name, ID, phone number.
ID, you got name, P, as, I think I'm just doing P dot owner ID. And in theory, this works. It did not. What's the issue? Oh, duplicate name as owner name. All right. So now I have this view called test view. And you can access test view as if it's kind of like it's a table. You can do select statements from it. And you can do merges with it, but under the hood, all this is doing is executing that same select statement that we made earlier.
I see. So it's like a macro.
Yeah, it's kind of like a macro.
Okay.
So that's how you can create a view. So why would we use views? Why do we want them? So in this case, imagine we don't just have one owner. We don't have like two owners. Instead, we have 200,000, right? And we don't have 3 pets. We have 300,000 pets.
Oh.
Because we're a big company, and that's how many people we have data on. We want to be able to easily
100,000 owner tables?
Not owner tables. We have 100,000 rows in our owner table.
Oh, okay.
So we have 100,000 owners, let's say. So we want to be able to easily look up, given some pet ID, who the owner is. And you can do that using the complex merges and stuff. Or you can just say select star from review db.testView. Because this test view merged the data for me.
Okay.
Select from that where ID in 1, let's say.
Basically, after you wrote some really long, complicated query, you want to save it and react.
Pretty much. Yeah. Pretty much. It lets you save your queries, and it lets you.
Interesting.
Yeah.
1 meaning, is it like the row?
ID. So
ID.
there's an ID column. ID is 1. ID and 2.
Oh, that's cool.
Like if I wanted multiple users, I could say 2, 1. I would get me the first 2 users.
Yeah, that's totally useful.
So yeah, in addition to that, like if we really wanted to, we could create a table that merges them. The issue with that is that you'd end up with a lot of duplicated data.
Yeah, right. Yeah.
And we don't really want that. We want our application to be lightweight and not abuse our memory and abuse our disk, because we're nice developers who want to use as few resources as possible.
I see. So this is SQL. This is what SQL developers do?
This is one of the creating good views is one of the things SQL developers would do. Okay. One of the many things. They do a lot of things.
I see.
So the most important thing a database manager would do is actually figure out what the structure of your database needs to be in order to support your application. Like you remember, nah, I don't remember where it is. Why isn't it there? Ah, crap. Tools, scripting. Reverse engineer, that's what I'm looking for.
Yeah.
All right, you remember this thing that the
Yeah.
professor showed us?
A database manager would design that.
So what this is reverse engineering the database. The database engineer would do the initial engineering.
Okay.
Let's just execute. Give this a second. All right, this is not a very complicated database, but even still, you can see that there's connections all over the place.
Yeah.
And some database engineer had to think about what data we were trying to store and figure out how it's all related and figure out what data we need to store and where we need to store it. And they're going to think about it and draw diagrams that look something like these.
I see.
And then they're going to create the tables, and then they can start loading in the data, and then they can do whatever other support the application needs in order to get working. But
I see.
the most important thing database engineers do is figure out how everything is related.
I see. That's why they get paid so much money.
They can. The job is, I don't know.
Can be pretty.
Seems to be from what I hear. But and yeah. This is also a useful diagram if you're trying to interact and do those complicated queries, because you can figure out how two tables should be joined and stuff. But
yeah, I had to look at that for some of the homework questions.
Yep.
I see. Well, thank you, Nolan.
Any other questions from anybody else? Caroline, you've been hanging out. Your mic is muted. I don't know if
Yeah, sorry, because I was with my daughter, in her class. So going back to the alchemy, Nolan, yeah. So you did not create a database, right? I mean, I didn't see, the top part.
No, I did not. Here I'm creating tables.
The tables.
Connecting to a database that already exists.
Okay.
Mm-hmm.
So where? There. Okay. Okay, and the engine. Okay.
You can create databases. You can create databases using SQL Alchemy. I just didn't want to have to show you guys that, so I just made it from within SQL Workbench in order to try to keep this simpler.
Okay. Okay, so alchemy is something different. Sorry, I missed that. Is that a different library or?
No, this is SQL. I'm using SQL Alchemy here.
Okay. And then what is declarative base? I mean, what's the purpose for that?
It's like a library. Is it?
Yeah.
It's something that you have to import. It's like a bunch of code that someone already written.
Yeah, basically it's a,
because
let's call it magic for now, and it's how SQL Alchemy knows that these objects that I define as classes are meant to be treated like tables.
Okay.
As opposed to if I just define some other class foo, right? And it does nothing. This class actually does nothing. It just passes.
Okay. Oh, so it somehow connects them, or
So I called declarative base in order to get a base.
Okay.
And then when I create a class that's meant to be a table, I pass in this base
Okay.
to the class definition. And that's how SQL Alchemy knows that this owner's class is meant to represent a table.
Okay. So it makes it recognize it, something like that.
Something like that, yeah.
Okay. Okay. So which one's important to remember here? So this one, so that's creating the table. That's where you start. And then what's the session? I saw a session part.
So a session is what you guys have been using throughout all of those activities on Monday. You guys were creating sessions. And a session is like a connection. It's an instance of, it's a thing that lets you communicate to a SQL to a SQL server.
Okay.
It's just it's a built-in object that you can. It's an object in SQL Alchemy that lets you connect to SQL servers.
Okay. It's like literally a session going on, or allows you to have a session, something like that. Okay.
Yeah, and then you have the commit. That's also very interesting.
Save it. Okay.
Well, commit is basically, so SQL Alchemy is not actually doing much when you call add. That's just staging your additions to be made. It doesn't actually make any changes to the database until you call commit. It's kind of like in Git. If you git add a file, that doesn't really do much other than make it so that Git knows to track it. It isn't until you actually say git commit that it takes a snapshot and saves the data.
Okay.
That kind of makes sense?
Yeah. Like a signal that,
it's a similar concept, yeah.
Okay.
Yeah, it's like a whole new world.
I think so.
I feel like we're finally getting into the programming part of this whole thing.
I think we need to practice, I suppose, to just be familiar with the syntax.
Almost any time you're going to be working with these, you're going to have the documentation open in some other window. And you're just going to be looking things up. I had to when I was writing this. That's normal. You use documentation. Documentation is your friend.
Okay.
Okay.
Oh man.
Like, don't try to memorize all the syntax. Just try to understand generally what's happening. And if you want to look at this is a tutorial that walks you through, as well as gives you access to the documentation. But this is the tutorial, which will walk you through how the SQL Alchemy ORM works. It's not the best tutorial ever, but it's the one that they made.
Okay.
Is there a better one?
Probably. I didn't spend a lot of time looking for one.
Okay.
If you find a good one, post it to Slack.
Gotcha.
For now, I would be most concerned with getting the SQL homework from last week finished as soon as possible. I'll be expect me to upload the next homework tomorrow. So you guys want to start working on that as soon as possible. Okay. I strongly recommend staying ahead on your homework because upcoming homeworks are going to get complicated really quick.
Oh man. Yeah. And it's confusing also, how to call a class or how to call a method. Do we call a method? I mean, how do you start? You start with a class dot or?
All right, so this is me defining a simple class.
Okay.
The class keyword, you give some name, and then a colon. You have one indent level, and then you can define methods using the def command, the def keyword. So like if I want to define def some stupid function self, this is going to take in an argument called x, and it's going to multiply x by 5. In order to call that method, I need to create an instance of the class by invoking the dumb class constructor, which is just calling the class name and then parentheses. And then I can invoke the method by calling the method and passing in some integer 5. What's the deal? Oh, sorry. Rename this. So this is not a function, it is a method.
Okay. Okay.
5 times 5 is 25. Hooray!
Okay. Oh, okay. So that's how you call it.
Yeah.
Okay.
You create an instance of the object using the class name, and then you call methods by accessing them as if they're attributes. dc.someStupidMethod.
Okay. So many to remember. Okay.
Yeah. Let's think I'll figure out a class first.
So different than like, you guys remember working with pandas and like doing, so let's just like import pandas as PD, x equals PD dot data frame.
Oh, that's right. So that's how you call. You're like calling it.
Yeah, this is me creating a data frame object.
Yeah.
Because data frame is a class.
Okay.
Pandas define class. And let me just quickly add some dumb data, 0, 1, and 2, 3. Quickly verify that that works.
Can we have a session just on data structure in the future?
What do you mean by that?
Like, because class object, these are things that we've been using without really knowing what they are.
Sure, but every class object, every class is going to have its own data structure.
Oh, okay. So I don't,
like data frames.
I'm not even sure about the definition of data structure, but they seem really relevant.
Well, yeah.
Yeah.
It's
just like understanding the data frame is a class. I feel like that gives a lot of insight.
But yeah, so data frame is a class. I create an object. I create a data frame object by invoking the constructor, which is just done by invoking the class name, data frame. And then I can access methods by just, once I have that, I can say x.min. And min is a method. Or in theory.
Okay.
Yeah.
Okay. I know. We need a session on class, huh? Class, methods, constructors.
Yeah. Those are terms I kept hearing.
Right?
Single class I took, and I never truly understood what they meant.
Okay.
Well, thank you, Nolan. This is an eye-opening session.
Yes. Thank you.
Looking forward to more to come. Like I said, try to get your homework done as soon as possible if you haven't already, and be ready for class tomorrow, and I'll plan on uploading the homework for next week.
Oh my gosh.
Sounds good.
For sure.
Take care, everybody.
Okay.
All right. Thank you, Nolan. Have a great evening. Bye.
Bye.